All right, guys. So, the thing about these word problems is that they're very applicable to our real world. Any object dropped or any object launched, that's kind of a big deal. There's a lot of launched and dropped objects out there in life. So you will have it's a guaranteed test question about one of these formulas. The good news is you don't have to memorize it. Okay, so the formula will be provided to you within the question. However, you do have to understand how to plug into it and solve it. So for number 1 on page 236 for the dropped object, something like negative 16t squared. Actually, it doesn't say y, does it? What letter does it use? H, because it's talking about height, the height of the object over time. So the height is negative 16t squared plus s with a little 0. So t equals time. I did this yesterday with 5th, 6th, and 7th period after the right score. They were super happy to be doing math after that. So I'm giving you a heads up that one thing they didn't realize when they got into the problems, that t is time. Okay, so let's go ahead and write that down. H is height. Did anybody figure out what s little 0 is? What type of height?
Initial height.
Initial height. So that's at time 0. Before the object is dropped, you put that at S0. Maddox, did you get that? Okay. Maddox, what's number 2 if something's launched? How does that change things?
It goes up.
Actually,
It's plus V and OT.
yeah, there's a V, there's a velocity, a speed that goes with it. And actually, sometimes things are launched straight down, Maddox. There's actually an example there. Sometimes things are launched straight down. Like a volleyball. Good. Okay, so for the launched object, negative 16t squared plus v 0t plus s sub 0. So the only difference for the launched object formula is this v0, and that is the initial vertical velocity. So something dropped just has the pressure of gravity. Something launched has pressure acted upon it. So let's look at the volleyball example that Maddox noticed. I like those pictures there. You can launch something up or you can launch something down. Okay, so yeah, your velocity will be more than 0 if it's going up, like a golf ball gets hit up. That's going to be a positive number. That's working against gravity. And the gravity bit is the negative 16. Now, some textbooks actually, it's really cool. They have you do problems on Earth and then problems on the moon. And it's the same formula, but the moon will have a different A value. It's less gravity on the moon, so it'll be something less than 16. And then if you were to go somewhere with stronger gravity, this number would be higher than 16. But other than that, it's the same formula. So the gravity is a negative number. It's going down, pulling things down to Earth. So when you launch it up, your velocity is positive number going against gravity. And then if you launch it downward, like a spiked volleyball, it's a negative number. It's helping gravity. It's going faster downwards. And then straight velocity, vertical velocity is 0, like an arrow. So a little bit of physics here, which is nice. These models assume that the force of air resistance on the object is negligible. These models apply only to Earth. Planets with stronger or weaker gravitational forces, it's just a different A value. All right, I don't love this first example. It's about a juggler. I wish it was about a rocket launch or something. But it's a juggler, so we'll just have to go with it. Or I was thinking about drone shows. Has anyone seen a light up drone show? Those kind of go up and fall a bit. Or even an object in a factory on a conveyor belt, you know? Okay, so anyway, a juggler tosses a ball in the air. The ball leaves the juggler's hand 4 feet above the ground. So that 4 feet above the ground is going in the S0 spot. That's the initial height. The vertical velocity is 30 feet per second. Do you guys think that's fast? Is this juggler really whipping that ball in the air? Or is it slow? A lot of people say it's fast. So 30 is going in the V0 spot. The question is, will the ball get 10 feet up? So, and this could go for anybody. If we're throwing it 30 feet per second, does it reach 10 feet? Or does it reach 25 feet? So, the question for 10, you're going to take the H value out and put 10 in. Does it get to 10 feet high? Because H is for height. Then to solve it, we're going to subtract the 10 to make it equal 0 and use the quadratic formula. So just, I know you weren't in class yesterday, so here's a reminder. We're still working the quadratic formula. And solving this out, you get two solutions. T is 0.2 and T is 1.6. Which one do you think it is? When does the ball, do you think it takes 0.2 seconds or 1.6 seconds just to go 10 feet? 0.2? What about the 1.6? Do you think that's just like a false answer? Yeah, it feels like it, but actually it hits 10 feet twice. And the ball's not going like this, but it's going, this is a visual. It's starting 4 feet up. It's flying up. It hits 10 feet after 0.2 seconds, continues to go up, turns and comes back down. It's at 10 feet again after 1.65 seconds. Which I don't really believe. Because there's no long, that means it's up here for a, oh, maybe that's like hang time? Like 1.4 seconds just chilling up here to get, well, here they put it in Desmos. And it's nice to see the visual. Here's this actual picture. The vertex is at 0.9, so it hit its median 0.9 seconds, and it went up 18 feet. Yeah, so it had to go up 8 more feet, turn, come eight more feet back down. So I guess I do buy into that. Okay, so yeah, 10 works out. The answer is 0.2 1.65. Now you do the same thing with a 25. Does it get 25 feet high? Subtract 25, do the quadratic formula. The answers are imaginary. Negative 144 is the discriminant. We left off with this the other day. I want to remind you about this word, discriminant. And here the value is negative 444. And I had you guys enter these on Big Ideas so that you would check it and realize some people were solving too far, some people weren't solving far enough. So in this case, b squared minus 4ac is less than 0, which means there are two imaginary solutions. And whenever you're doing these real world problems and you get imaginary solutions, the answer is no. It does not reach a height of 25 feet. The result is imaginary. So if it comes out I, you say no, it doesn't go that high. Okay? So it's really like a yes or no question. Yes, it hit 10 feet. No, it didn't hit 25 feet. All right, everybody, let's try number 20. This is the only example I'm doing with you today. And then I'm only assigning you 2 word problems today. So you have a lot of time in class to get it done. I just have to check some assignments. But this is pretty much it. So everybody do number 20. And I put a little note here that this is a guaranteed test question. Because, and I'm doing that because every year it's a very challenging test question. So it's so challenging, I'm telling you ahead of time. This is on the test. Try to figure it out.
So it's like guaranteed like those exact numbers.
No. No, not these numbers. I guarantee you it's not these numbers. It's this formula and this wording with different numbers. It probably won't be about a juggler. It'll be about something else. So is this dropped or launched? This is launched, right? It's getting thrown. So I'm going to start with the model. You don't have to memorize this. It'll say use this model, but you have to plug into it correctly. Same 4-foot juggling situation. The ball leaves the juggler's hand with 40 feet per second. So they're putting a little more effort. They want the ball to go higher. They're throwing it faster. So we're going to put a 40 in. So this is the function we're working with. It's 40 feet per second, starting out at 4 feet high. Will it get 20 feet? Will it get 30 feet? Not enough room. Not enough room to decide. I'm going to do it on the board. I'll do the 20 feet on this side. Everyone needs a calculator. Oh, you know what I really want you guys doing is I want you guys practicing putting this whole thing in your calculator and hitting enter once. I don't want you doing this in lots of separate calculations. I want you really getting good. Your TI-36 calculator, not that desk calculator. If you have your TI-36, use your TI-36. It's 40 feet and 30. Oh, I messed it up. It's 20 and 30. Yes. So they're saying it's this same juggler. So I'm using the 4 from this problem. But they have to tell you that. They have to tell you the initial height. So it's not that clear in the book, but that'll be given to you. So this will be 30 feet. And this one over here will be 20 feet. This is number 20. Holy cow, this is a long section. Before you can do the quadratic formula, you always have to set it equal to 0. So we're pretty much questioning, can this thing ever equal 20? I'll write the formula out. I hope you guys are very close to having it memorized, especially since we took the time to derive it. And I'll plug in. Maybe I'll make a list. Whoa, I didn't write that. So minus 16 up there. So using your calculator, using your tool correctly, you should be able to type all of this in just like this and hit enter once. I want you to practice that now, particularly when you're working with word problems. There could be decimals or really big numbers. Practice it. You can't put plus or minus in the calculator. So do 1 with plus, and then go up, highlight it, enter it, and then do 1 with minus. But you should only have to type it out once to find both answers.
How do you get the letters?
Well, this has no letters in it. So you put all of this in the calculator at once. Hit the fraction button, negative 40 plus square root, put all that in, and then put this on the bottom and hit enter once, and it should tell you the answer with just one calculation. Oh, I have x equals, but you know what? It should be t equals because we're solving for time. Mm-hmm. Tuesday. Your test is Tuesday. November 4th, yeah. Fun.
In the formula, it says I need 4 times A times C. And on the bottom, you put negative 16 R.
Sorry, this is C. Oh, I have it written here on. C is actually negative. A and C are actually both negative 16.
How do you get negative 16?
I subtracted this 20
Where'd you get the 20?
because we're trying to figure out if it'll make it 20 feet. That sounds legit, doesn't it? It sounds very legit. Yes.
It's negative 40 all time.
Yeah, let's just hit that fraction button as your very first button and put it in like that. Look, the whole thing should go in at the same time like this. Start with the fraction button. Sometimes if you hit this number when you mean to do the negative, that. Okay.
Yes, I put the 16s on the numerator in parentheses. Does that work?
Yeah. Negative 40.
It says syntax error for me too.
That's crazy. What's going on? Mine is exactly like yours. Okay. Such a good question. I put parentheses down there and got it to work. How'd you get it? What'd you switch?
I put the parentheses at a negative 16.
Wow, that's so annoying. Okay, in the calculator. Ooh.
I do not know what my calculator is.
Ooh, you gotta find it.
I don't have that calculator, so I wasn't able to plug it in. I don't know what I'm doing.
You should get the calculator.
I can't.
Share this one.
I did without it, but I didn't. So for this one, I had got this right here. Cause I had did these.
Mm-hmm.
That's the try date.
Mm-hmm. And so now you just have to square root 576, like this, Jalen. Are you doing it all at once like that?
So it'll be negative. I got it.
Hit the fraction button first. And do it all.
So I got 24 when I square rooted.
Good. And then keep it going. Quinn, didn't you have the calculator?
No, I'm.
Oh my gosh, how much more time is there this year? We got November, December, January, February, March, April, May. 7 months divided by, what's $20 divided by 7 months? It's like $2 a month to go out and get this calculator and your whole life is easier. You guys, who has the calculator? Little raise your hands. All right, how much do you think it's making your life easier? Like, speak into it. Tell the people. Life is easier. Don't you want it to be easier? It's so worth it. Get your calculator. What?
Are you sponsored?
No.
You sponsored, miss.
Look,
You getting commission.
I am getting commission for you to participate. Like, it's my job to encourage you.
I got the main arrow for the second
This is better. Hit the fraction button
I did not
first.
do that. That's what I didn't do.
Good job, Calista. Good job. That is a good day.
I'm confused about this one because I tried it with the -26 and it keeps saying error. But I only changed the -26 because it's.
What do you mean 26? No,
we do
negative
30.
26. That's a negative 16. Oh,
With 30?
no, that's because it's imaginary. Mhm. So let me finish this one. All right, so your answer is 1/2. And then when you subtract, oh, it's an even 1/2. And your answer is 2. So we need to answer this in a complete sentence to show that we actually understand what we're doing. We're going to say, yes, the ball reaches 20 feet. When thrown 40 feet per second. And it reaches it after half a second and 2 seconds. We got real number answers. So that's true for everybody, by the way. Right now, anybody in here, if you throw the ball starting at 4 feet, 40 feet per second, it's going to go at least 10 feet up. Those are facts. Now we know how high the ball goes. I'm going to do this one by hand for everybody who's not using the good calculator, which I have been doing all along, but all right, so I do 40 squared in the calculator and it comes out 1,600. Then I do negative 16 times negative 26. Yeah, this is for 30 feet. And I get minus 4 times 416 over negative 32. So 4 times 416 is 1664. And then I do that subtraction and I get negative 64, which is syntax error in a calculator. Your calculator will not square root negatives. This is an imaginary answer. Our discriminant is negative. The square root of negative 64 is 8i. That can be reduced by 4. Is this really a 4 here? I thought so. I dropped my 0 in my work. Okay. Divide everything by 8, and we're at negative 5 plus or minus I over negative 4. And so our answer then is that no, this ball will not reach 30 feet. We did not get a real number answer. I'm going to write complete sentence on the screen since I don't have room over there.
No, I'm talking about.
The answer is in the imaginary or complex coordinate plane. Okay, any questions? So this reviews the discriminant, talks about negative radicands, and it reviews the quadratic formula, and now it's using the launched object formula. I have to look at my gradebook and see what exactly I have to grade still for third period. And so then this is your assignment. It's page 239, 34, and 40. Make sure you answer using complete sentences. And it is exactly this exact same type of question.
kind of fun to do.